Okay, section 15.2 is going to talk about what's called U-Substitution. There's cases of integration that we don't know what to do. We don't have any rule for it, and so we try to rewrite the problem so that we could do it with a rule that we have. And there's three main cases that we're going to look at. So there they are. You might use U-substitution in any of these three cases, either the quantity under a radical or a quantity raised to a power, the exponent on e. So if it was e to the 5x minus 3, then maybe that part that is the exponent, or the quantity in the denominator of a fraction. If you see those three cases, you're going to be looking at it saying, well, I don't know how to integrate that any other way. I guess I'm going to use U-substitution. All right, here's an example. Can I move that up just a little bit? There's the problem. The integral of 2x minus 3 over x squared minus 3x dx. Okay? So this is that case, quantity in the denominator. Okay? And what you do is let u be whatever we've talked about. So this part here in yellow, u is equal to that. Then you take the derivative of that in order to rewrite this. What's the derivative of x squared minus 3x? It's 2x minus 3. What you have to make sure is that you have everything taken care of to rewrite this. You have u, that's there. And then you have this green part, which is the du. Okay? So we can now rewrite that problem using that substitution. How did I get 1 over u? That all cancels out to du, and it's going over to the side. That leaves 1 on top. I said this was u, so I have 1 over u du. We know how to take the integral of 1 over u. There's a rule for that. So that makes this problem easier to do. So that's equal to ln u plus c. ln u plus c. And the last step is to substitute in for u whatever you've said. And you have to be sure that you add in the plus c. So you want to rewrite it so that it's easier to look at, easier to solve. 1 over u, we know how to do that, or in theory we do. All right, questions over that so far? Make a little bit more sense once we get going on the problems. Okay. For you guys that just walked in, we just did the kind of notes section on this 15.2, so you'll have to look at that part, but we're about to do the problems. Okay, let's look at the problems. Okay, so the first problem in the set is the integral of 5 times 5x minus 10 to the 4th. All right, this is something raised to a power. That's one of those instances that we talked about on the first page. So let u equal 5x minus 10. Take the derivative of that. So du would be 5 dx. What you want to look at, and what I've put in yellow, is do I have everything taken care of? There's a 5, there's a dx. That's taken care of. Here's my u. So I've taken care of everything. I'll rewrite the problem. So now I have the integral of u to the 4th du. I'm substituting so that it's easier to see. I can take the integral of u to the 4th. It's u to the 5th over 5 plus c. Does that make sense, what we're doing? Because if we don't do that, we don't have a way of solving this problem. And then you substitute back in, put your u in, you have that thing to the 5th over 5 plus c. Okay? Or it could be written 1/5 of that plus c. For me on the test, either way, I think this way is what you'll need on Math Lab, but I'm not positive. Questions so far? Can I move it up a little bit? Okay, let's look at number 2. Number 2 has the integral of 8 over 8x plus 9 squared. Okay, remember we talked about something in the denominator, also something raised to a power. So it makes sense that this guy here is going to be our u. If u is 8x plus 9, the derivative of that is 8 dx. We've got 8 dx, we've got 8 dx. Those two are taken care of. So we could substitute. What would it be when we substitute? Those are gone. We're left with a 1. 1 over u squared is what we get. And that's easier to work with if we make it u to the negative 2 du. If you integrate that, you get u to the negative 1 over negative 1 plus c. I've been late this morning. So then substitute back in. Put the 8x plus 9 back in there. And write it without the negative exponents. Okay? Questions? If you walked in before we got that general explanation, you'll be lost for a little bit, but hopefully we'll catch up. Okay. Let's look at the next one, number 3. 48t to the 7th, e to the negative t to the 8th. What was one of the cases that we said to use for U-substitution? The exponent on e. The exponent on e. So, if we let u be negative t to the 8th, the derivative of that is negative 8t to the 7th dt. Well, works out nicely. Here's t to the 7th dt. Here's t to the 7th dt. But what do you notice? We don't have a negative 8 up there. This is the first one we've had that didn't work out perfectly. And so this guy right here, we have to do something with. This right-hand side has to take care of these up here. So divide by that negative 8, and you get negative 1/8 du equals that. So now the yellow parts match. Okay? If you have something out here in front of du, pull it through the integral sign when you rewrite. So rewriting it, you have 48 because it was already outside. You have a negative 1/8. Then you have an integral of e to the u because u was this thing up here. E to the u du. Questions? Does that, when you come up with a number here that's not matched, you've got to divide through by it, and then it can go on the outside of the integral. So 48 times negative 1/8 is negative 6. And the integral of e to the u is e to the u. So we end up with that. Number 5. Why do we choose what I've written to be u? Why is that what's going to be u? Do I? Did I skip 4? It's a hope. We must be omitting it. What is number 4? Does it look ugly? That's why we're omitting it.
Okay.
We'll omit it for you guys. We're down to the wire. So omit number 4. I don't know if it's already omitted on the math lab. If it's not, when everybody's done, I'll go back and add a point to everybody's on that section. Thank you. Just remind me. Okay. My question was, why would we choose this to be u? Why not this thing? Anybody? It's a quantity raised to a power. This thing, we could do something with this. We don't know how to take the integral of it. So let that be u, and then take the derivative of that. When you take the derivative of this, you get 4x cubed plus 8x dx. I'm not getting this, but I'm looking at this saying I could factor out 4, and then I see that I have x cubed plus 2x. Divide that 4 on the other side, and you get 1/4 du equals this part. So now I've matched. Okay? What happens to the 1/4? Where does it go? The outside of the integral when you rewrite the problem. So you have 1/4 the integral of u to the 5th du. Okay. What's the integral of u to the 5th? U to the 6th over 6. If you can get it to u to the 5th, that's pretty easy. So you have 1/4 of u to the 6th over 6 plus c. And then you plug back in whatever u was. And where did this 24 come from? 4 times 6, 24. So here's your answer plus c. Okay. Because this test isn't multiple choice, you're going to have to remember all those little pieces. It won't be just choosing the answer. You will have to, make sure that you don't forget the c's and that sort of thing. Questions on that one? Okay, 6 is a little weird, so let's look at 6. Okay. It starts out fine, and we say, okay, this thing's raised to a power, so let's let u be that. If u is p plus 7, du is dp. That's easy enough. But what do we not have? We don't have that. We don't have another p there. We can't fabricate that. We can't divide a number. We just don't have what we need to have. When you see one of these that ends up like that, take where you had u and solve it for p. That means I subtracted that 7 to the other side. So I'm saying p is u minus 7. And the reason I did that is that I can put p in terms of u in my substitution. So this is that one step that we haven't done before. Okay? So now when you rewrite, p becomes u minus 7, p plus 7 becomes u to the 7th du. Okay? And before you try to take the integral of that, you want to multiply those out. So u to the 7th times u gives you u to the 8th. U to the 7th times minus 7 gives you that. Now you have two little pieces. What's the integral of u to the 8th? U to the 9th over 9. Okay? And then we have minus 7 u to the 8th over 8 plus c. And the last step is just plugging in the pieces that we substituted. And your final answer is there. Questions? You'll have one like that on Math Lab, and just understand that when you don't have that p and you don't have it covered, when you take the derivative, you've got to do another substitution. So be careful with that one. All right, at this point, number 7, I'm not going to pull that up. Number 7, does everybody have their questions there? I want you to try number 7, deciding what's u, what's du, and then rewriting. Does anybody not have their questions with them? At least somebody has questions? Oh, now we're having to dig in the bags and get them out. And remember the 3 cases where you let u be something. If you don't remember that, look back at those first notes. Are you stuck? Are you stuck? We're working on number 7. He's just zoning out. Did you pick what was in the radical to be u? Because that's the choice. This piece is not raised to a power or anything. This piece is in a radical. We don't know how to take the integral of that. So if we let u be that, how nicely that works out that we have 9t to the 8th plus 5 dt. That matches that. Okay, so when you rewrite it, what do you get? What's the problem when you rewrite it? The integral of u to the what power? 1/2 du. And what is the integral of u to the 1/2? You're going to add 1 to it and divide by that same number. So what's that going to be? U to the 3/2 over 3/2. And whenever you're dividing by 3/2, you'll get real familiar. You flip that. So you're going to have 2/3 u to the 3/2. And when you plug back in, that's what it looks like. Okay. U-substitution is one of the harder concepts with integration. Just recognizing what to do and how to do that. So, takes a little bit. Okay, number 8 is the integral of 19 over x ln 7x. This one's not as easy to see because you're tempted to say, okay, that's in the bottom, but you can't take the derivative of that very well. That'd be a product. So think about it this way. What is the derivative of ln? What's the derivative of ln x? 1 over x. Well, here we've got 1 over x. So that's going to kind of work for us. So if you let u be ln 7x, then du is 1 over x dx. Because it's actually 1 over 7x times 7, which ultimately becomes this. So we have 1 over x dx. So we're all taken care of. When we rewrite it, we have 19 on the outside, because I just moved that out. That left the 1 up there. 19 times the integral of 1 over u du. What is the integral of 1 over u? ln. So it's 19 ln u plus c, but u was ln 7x, so when you substitute back in, you get that weird answer. 19 ln 7x plus c. Questions? Okay. Try this problem for me on your own. Find the integral of that thing. It's kind of a little twist on what we've been doing. What would you be?
3x squared minus 1.
And what's the derivative of 3x squared minus 5?
6x.
Not 6x minus 5. 6x dx. Do we have 6x dx in the problem? No. But we do have 2x dx. So what do I need to divide by here? 3. So 1/3 of du equals 2x dx. That's the thought process that needs to go on. So what do you get when you rewrite the problem? You get 1/3 the integral of u to the 4th du. And what's the integral of u to the 4th? U to the 5th over 5. So what's my final answer? Anybody? Ryan? Yep. That's it. Okay. Any questions?